Hello guys, welcome to the Guess the Secret Number challenge. Your challenge is to develop an application that saves a secret number between 1 and 100. Then ask the user to put a number. Finally, compare their guess to the secret number. If the number is lower than the secret number, you have to inform the user to guess higher. If the number is higher, tell them to guess lower. But if they guess the right number, congratulate them, display the number of attempts, and exit the application. Alright, pause the video and work on the challenge. Take your time and have fun with it. Alright, let's dive into the challenge. Okay, we begin by declaring an int variable and assigning it a number between 1 and 100 as a secret number. Let's make the secret number a constant since we don't want it to be changed. This will be the number the user needs to guess. Okay, to keep track of the number of attempts, we use an int variable. Following that, let's print a message to the user informing them to guess a number between 1 and 100. Next, we create an infinite while loop that allows users to guess the secret number as many times as they want. Inside the loop, let's ask the user to put a valid number. Next, we store their guess in a variable. Now, let's increment the attempts variable by 1 to update the number of attempts. After that, we use the tryParse method to validate the input. If the guess is not valid, we show an error message. Then, let's use the continuous statement to start the iteration again from the beginning. By validating the user's guess, we ensure that only valid inputs are accepted. Now, if the guess is valid, we'll compare the guess with a secret number to determine if it's higher, lower, or equal. To achieve this, first, let's check the input is equal to the secret number. Inside the if block, we congratulate the user. Then, let's print the number of attempts. And finally, terminate the application by using the break statement. Okay, now let's check if the secret number is higher than the guess using the else if statement. inside the else if block, we give the user a clue by displaying a message. Okay, if neither of these two conditions is true, we can be sure that the guessed number is lower than the secret number. So, inside the else statement, we display a message that says the secret number is lower. Alright, we're ready. Let's run the application and test it out. First, we put an invalid number. As you can see, we get a message that tells us our guess is not a valid number. Now, let's add a number between 1 and 100. As you can see, the application correctly gives us a clue, saying that the secret number is higher than 50. Let's try 75. Okay, it continues to indicate that the number is higher. So, let's put 90. Based on the clue, we continue until successfully guess the secret number. As you can see, after we correctly guessed the secret number, the application congratulated us and printed the number of attempts. Alright, to make the game harder, we can limit the number of attempts to 7. To achieve this, let's declare an int variable and set it to 7. Now, instead of true, let's add a condition indicating that the while loop should continue until the attempts is less than the max attempts. Additionally, after the while loop, let's show a message informing the user that they have run out of attempts. Also, let's display the secret number. Okay, in this statement, after we correctly guessed the secret number, the break statement terminates the while loop, and the application continues and displays this message. To avoid that and terminate the application immediately after correctly guessing the secret number, let's utilize the return statement. Now, let's run the application again and give it a try. First, let's quickly use all 7 attempts and see the result. As you can see, after the 7th attempt, our application correctly displays a message saying that we're out of attempts and also print the secret number. Okay, let's run the application once more. This time, after several attempts, we correctly guessed the secret number. As you can see, we get the expected result. Okay, done. See you soon in the next lecture.